Hey, Scott. Can you hear me? I don't think Scott can hear me. Mm. Is it still not working, Scott? Are you back on your Wi-Fi or are you still on your hotspot? Is it working yet, Scott? Can you hear me, Scott? Do you have yourself muted, Scott?
Oh.
I can hear you. Is it just not sharing your video or your PowerPoint?
Oh. Can everybody hear me now?
Yeah, we can hear you and see you.
We're having issues being able to share the PowerPoint presentation.
If you hit, Scott, if you hit the computer monitor that has a red line through it, is it working at all? I think we lost him again. I don't know either. I'm not sure where he went. Yeah.
Can y'all see the slides?
No. Scott, what internet browser are you using?
Chrome.
Are you on Chrome? Okay. I was saying if you're on Internet Explorer, sometimes it won't work right on Internet Explorer.
Yeah, I made sure to get off that. I've got it now where I have it up, but it won't allow me to share.
Do you have the PowerPoint opened up on your screen? So open your PowerPoint first before hitting the share button.
Here we go.
There we go.
All right. I just logged all the way out and came back in, and it allowed me to, at that point, I could use the monitor button.
Okay.
All right, so
you should be able to go, I guess. I can see your computer screen.
Can you see the PowerPoint now?
No. When you selected the share your screen, did you select application or did you select screen your computer monitor to be able to share?
I went to the application. Jeez.
Can you get it to work, Scott?
I mean, I can get to the application window and I can get to where click share, but and then when I go to hit the PowerPoint, y'all can't see it.
Is there a white box that opens up that you have to hit share, Scott, when you open up your PowerPoint?
Yes.
Hit that button.
Not when I open the PowerPoint.
Click. There you go, Scott. Okay, I can see it now. Okay.
Is
that's it?
Okay, it's not application, it's share entire screen.
Oh, he said it's share entire screen, Kim. Okay.
So, all right, are we ready to go?
I think you're ready. I'm going to leave so you can do this, Scott.
All right.
Hey, bye. Bye.
Now,
Are you good to get going?
well, I can't see any of the comments, so any of the chats I'm not able to see. The only thing I can see is my PowerPoint.
Now we can't see the PowerPoint. I don't know what you just did. There it goes.
Yeah, I've minimized it so I can,
Okay.
but I can't. I mean, I'll just go, and if there's questions at the end, I guess we'll
Yeah,
hit 'em.
I will monitor the chat for you and I'll let you know. I can just turn off my camera and stuff and just come back up if I need to stop you for a question, okay?
All right,
All right.
thanks.
Uh-huh.
All right, so let's get started. I love the new normal that we have here in our world. I want to introduce myself. My name is Scott Green. I am currently a soil scientist for the state on-site water protection branch. I have been doing this for over 30 years now, and I've seen a lot of changes over the years, and hopefully this will be somewhat entertaining. Look back the way we started and to where we're at now. My career started in Guilford County, and 1988, I started working in Guilford County at that time, we were registered sanitarians. We weren't environmental health specialists, we were sanitarians. And a lot of things have changed over the years. A lot of things have changed in the past 30 plus years. And hopefully this will be an entertaining look back. First things first, what to wear. Well, when we first started, we were required to wear a coat, tie, at least khakis, and nice shoes. And when you went out into the field, you were allowed to take your tie off. That was it. You still had to wear your coat and your collared shirt, your khakis. You weren't allowed to wear boots. And this was working with wastewater. And so I think we felt like we looked like the picture on the left, but we probably more looked like the picture on the right, in all honesty. This was back in the days of the knit ties. And so you can imagine that we were wearing a lot of knit ties and probably didn't know how to tie them, and they probably didn't come down to the proper length, but yet we were styling and profiling. Nowadays, you go around to the counties and it's hard telling what you're going to see. You see guys going out into the field wearing shorts, wearing sweatpants. The guy in the middle there, he actually does work for Guilford County now. He's sporting his compression socks and shorts, but it's changed quite a bit. We saw that evolution from when we started till now, where they allowed us to not wear the tie, and then we got to wear knit shirts, and we thought that was something else. And then from knit shirts, we got to wear jeans, and it just progressed on where now they're actually wearing what's more comfortable. I don't know how professional it is, but at least it is more comfortable out in the field. Training changed quite a bit from the time that I started until now. When I started, you went through something called 3010G, where they had a site. Mine was Randolph County. I'll go on a regular basis down there and take the class. And at the end, we had to take a test. And then Barry Ingberg, some of y'all might know Barry, he taught the vector class. So we had to take that and pass the test. And you had to go to a county training site. Fortunately, Guilford County was a training site, so I didn't have to go to another area, but we would have people that were new into the field that would come to Guilford and have to work with us because we were a training site. I think Cumberland County was also a training site. It was the next closest one, I think. Nowadays, they go through centralized intern training, and that's changed quite a bit. When it first started, it was about 8 weeks long, six or 8 weeks long, and you basically went for that entire time. And now we've got it down to where you go to the general module, and then you go to either the food and lodging or the on-site or both, whatever the case may be. From having gone through both, I think centralized intern training is absolutely higher quality training than what we did, what we were able to do back in the day. So I think we've made some changes that are for the better. When I was authorized, I wasn't authorized by the regional soil specialist back then, they were called, or regional soil scientist. I was authorized by the district sanitarian. The district sanitarian at that time for me was Tucker Daniel. My regional soil scientist was Joel Cawthorn. I never met Joel Cawthorn until it was a couple of years after I was authorized. And so I was authorized by Tucker, and Tucker's strong suit was more food and lodging than it was on site. And so it was not until later that they allowed the regional soil specialist to do the authorizations of staff. So I was, I'm sure if y'all been around, a lot of y'all were authorized by the district sanitarian as well in on-site wastewater. We used to permit pump trucks. They would come to the office. We would have to do an inspection on them. And inspecting a pump truck is a lot like inspecting a septic tank. You're looking for leaks. You're looking for water type. You're looking for the records that they had to show us the records that they kept of where they would take and dump. But we did that. Nowadays, it's no longer with us. It's with a whole totally different department. I didn't inspect this one. I didn't approve this one, but this one has had an issue. Looks like they were in the midst of pumping and somebody hit the gas. Perc test, or is it Perc? P-E-R-K or P-E-R-C? Well, it's actually a percolation test, and it was when I started. Guilford County still did the Perc test, but if you talk to most people, most laymen out in the field today that you talk to, still refer to it as a Perc test. You see houses that are for sale or lots that are for sale, and it says it's already perked for a 3-bedroom. We no longer do a Perc test in North Carolina. There are states that do Perc tests still. North Carolina is not one of them. Guilford County was the last county to stop doing a Perc test. I remember it well. It was in first part of 1989. We no longer did the Perc test. We went to state rules where we did the soil evaluation. But there's been many days that I would go out to a subdivision and see just a sea of 5-gallon buckets laying around everywhere, where we would go and pour the water in the hole. So the Perc approval for Guilford was you had to develop a 60-foot triangle. You put in 3 holes. Holes were 30 inches deep. You had to nail it 6 inches and 10 inches. The applicant would pre-soak the hole to the 10-inch mark, and then when we came, we would pour it to the 6-inch mark. But people quite a bit learned how to be creative and getting a Perc approval. We had people who take a shotgun and shoot into the bottom of the hole. Had people that would overdig the hole and put gravel in and then put soil back over top of it. So you had to go out with a probe rod as well to make sure that someone hasn't altered the Perc test, that it was actually soil underneath the bottom of the hole and not something that would absorb the water. An approvable Perc rate was 1 inch per hour. So if it would hit that 1 inch, it was approved. We also would do 1 auger boring in the middle of the 60-foot triangle. And so if the soil looked good and the Perc was good, then it got an approval. This time, all we had was an auger. We didn't have all the equipment that we needed. We didn't have the Munsell color book. We didn't have water bottles to put the soil up, but we didn't have clinometers or Abney levels. All we had was we didn't even have a tape measure. We had just an auger and the Perc. So it's changed quite a bit. Now we're into the point where we now see a lot of work done with constant head permeameter. It's called KSAT, or saturated hydraulic connectivity. It uses Darcy's law, which is a product to figure out what the flow is. And the flow is the hydraulic connectivity K versus the area, which gives us a flow. And it's kind of like a Perc test, except it has a constant head. So if we set the machine up to put 6 inches of water into the hole, it stays at 6 inches. So as water goes into the soil, perks into the soil, it will stay at that 6-inch head. And so what we're looking for is once that soil column gets saturated, then we want to know how much water is percolating into the soil at that rate, at the saturation rate. And then we can use those numbers to try to confirm our long-term acceptance rate. We don't ever use the hydraulic connectivity to assign a long-term acceptance rate, but we do use it to confirm those. There are several units out there. There's one called the Aardvark, one called the Johnson Permeameter. The one that kind of started it off was the Permeameter, and that's the one in the middle of the screen with the white PVC tube. That was developed by Aziz Muzagar, who's a professor at NC State. He's done a tremendous amount of work on hydraulic connectivity and speaks at our conferences on a regular basis. So we've gone from Perc test now to where we are doing a full-fledged soil evaluation. This was a book written by another professor that used to be at NC State, Dr. David Limbo. David works now for the feds. He's now working in Washington, D.C. He is over all of those that go out and map soils. So if you've ever seen a soil map for a county, those that go out and map those soils, David is the supervisor of all those. So it's he says it's kind of a headache, but it's a job. But we now do a soil evaluation. So we're going to talk a little bit about soil evaluation. If you ever say the word dirt in front of soil scientists, they may come back with something like this, because a lot of soil scientists don't like to use the word dirt. They will use the word soil. An old adage, and I don't know if this holds water or not, but they would say dirt is soil out of place. So when you get soil on your shoe and you bring it into the house, then it's dirt. It's no longer soil. But if it's out in the field doing a purpose, then it is soil. So it's kind of interesting. Some people get really upset about it. I understand where people are coming from. So we do a soil evaluation now, and the one hole with an auger we used to do in the 60-foot triangle, we now do a lot more of those holes. And so that's what it would look like out in the field where we have an auger. We dig down into the ground. We're now digging down to 48 inches or to an unsuitable horizon. And a lot of times the first hole, even that at an unsuitable horizon, we'll dig it down to 48 inches just to see what else might be in that hole. And then as we progress, we may stop at the unsuitable horizon. That's an example of an auger. Yes, we still have pit privies. We have pit privies for houses still. We do not have new permits for pit privies for houses, but we can still write a permit for a pit privy. It's still part of our rules that if a camp wanted a pit privy, then we could write a permit. But we have to evaluate it. We have to evaluate the soil. We have to look at if that soil is deep enough to put the pit privy on top of it. I'm sure when they first started, that wasn't done. Here's some guys that y'all may or may not be aware of. They're actually not those guys, but just having a little fun. So we've gone from a pit privy evaluation to a pit evaluation. So what we used to look at a 2 3/4 to 3 1/4 inch hole, we now are looking at a lot of pits where the applicant will hire a backhoe operator, and they will come out and dig a pit. Usually it's going to be about 4 feet deep, and it will be wide enough for us to get in and do the evaluation. So 2 to 3 feet wide, and then like to have a step. This shows us a whole lot more of the soil profile than just looking at that one auger boring. Here's an example. The hand on the right is the soil that came from a pit. The hand on the left is the soil that came from an auger. If you notice, the auger boring was dug right beside the pit. So these are the same soil, but you can see the structure. We look at, one of the things that we look at as soil is the structure. How is it put together? Soil is put together like puzzle pieces. And so a lot of times you'll have subangular blocks that are side by side or angular blocks that are side by side. With that pit, it's a whole lot easier to see that soil structure than it is with the auger. When you dig that auger, you start to destroy the structure. So it's harder to see. And I think this kind of picture tells 1,000 words. I spoke at a conference and in hoping that we would have more people digging pits, and we do. We have some counties that they do all their evaluation with pits now. And I would love to see that in North Carolina. Unfortunately, there are counties that are adamantly opposed to pit evaluations. And so I don't know that I'll ever see it in my lifetime, but I think it's very worthwhile. When I started, when we were doing to test for a mineralogy, which would tell us if the soil was expansive or slightly expansive, we did a ribbon. If the ribbon was 2 inches long, then it was slightly expansive. If it was 3 inches long, then it was expansive. That wasn't in the rule, but that was the way that we were taught to do it. In the rule, it talks about whether or not it's very firm, very sticky, and very plastic. And so one of the ways to do very plastic is the picture on the right. It's where you wire the soil. And if you can get a wire that's 1/8 of an inch in diameter or less, and about an inch and a half or 10 centimeters long, and will support its 4 centimeters long, and support its own weight, then it would be very expansive, very plastic, which means it's expansive. So we've changed. The ribbon test was not a good test because it had a lot to do with the clay content. It's expansive clays will ribbon a long distance, but high clay contents will also give you that long ribbon. The wire is a little bit better of a test than what the ribbon is. In our rules currently, to do a lab test for mineralogy, it's called the Atterberg limits test, and it was developed by Albert Atterberg. Most of the Atterberg limits tests are done for construction, but we put it in our rules. You get a plastic limit, a liquid limit, and a plasticity index. Plastic limit is basically doing the same thing we do with our wire. You roll out the soil and you're looking at the moisture content of a certain length and diameter soil wire. And then the liquid limit, if you look at the middle picture at the bottom, it has a brass cup. And so you put the soil in there, a certain liquid, and you cut a groove in it with a grooving tool, and it bounces. And then you count the number of bounces till the soil comes together again. And depending upon how many bounces and what the liquid is, that's your liquid limit. And the plasticity index is the liquid limit minus the plastic limit. It's not a real good test for mineralogy, especially if you're in sandy soils. If you're in a sandy soil that has a lot of shrink swell clays, it will still pass the Atterberg limits test. So the best test that we found that's most economical is the cation exchange capacity, or apparent cation exchange capacity, where it measures the number of cations. And it's done if you've got at least 35% clay, and it's done under a certain pH, neutral normal, and you come back with a number. And if that number is greater than 16.3, then it's considered to be expansive clay. Less than 16.3, it's considered to be candid clay. When I started, the soil scientists that I worked with used the ABNY level. There's still a few of the counties that have these. Most counties have a clinometer. Clinometers are a lot easier to use because you can use it with one hand. And ABNY level, it does take two hands. Clinometer is a little bit harder to get used to because you have to keep both eyes open at the same time to use it. Whereas an ABNY level is kind of like a gun sight where you're looking through the barrel and you come up with your slope. But these are just to come up with slope. Why slope is so important is because we need to know what our slope is to be able to correct for our trench. When we dig a trench on a sloping site, the downhill side may be at 18 inches, the uphill side may be at 22 inches. And so when we do our evaluation, we need to know what that uphill depth is going to be to make sure that we're still going to have our separation from trench bottom to an unsuitable horizon. So this is a very important tool that's used out in the field, and we express this out to our centralized intern training. We do a lot with the clinometer, and we do a lot with slope correction because it is so important. When I started in Guilford, we had an issue. I was at work one day, and a guy came in and said, guys, I just got fired. They're getting ready to fire everybody. You better get out while the getting's good. And I was young. I just graduated college. It's my first job, and I just moved from Tennessee over here. So I was really worried. God, what have I got myself into? Well, the guy had done a lot of things that were wrong. He had written a lot of permits that he shouldn't have, and he ended up going to prison because of it. He was taking bribes. He did accept money for these permits that he wrote, and he went to prison. So we had to go back and look at all of his permits. And our health director at the time got us into his office, and he came up with this poem, I guess you'd say, of how we're supposed to evaluate the soil. And he said, if it's yellow, give it to the fella. If it's gray, take it away. Well, there's a lot of truth in that, even though it's very simple. If it's a true gray color, it's more than likely going to be a redoxamorphic color. It's a color that is indicative of a soil wetness condition. If it's yellow, then it's not got the soil saturation is not there long enough to where it would be considered unsuitable. And so we do that now. It's a lot more in depth than if it's yellow, give it to the fella. If it's gray, take it away. But it is something that there's a lot of truth in it. We now look at the soil with the Munsell soil color chart. We're looking for things that are redoxamorphic, which means that they are reduced and oxidized. So you may have really red colors, you may have really light colors. When you're looking at a soil and it has these gray colors in it, a lot of times what's happened is the iron has been depleted and moved to a different location. The natural color of the soil is not red. The natural soil color is white, gray, or blue. And the red comes from the iron. So it's basically just a rust on top of the soil particle. And as that iron gets wet, it can become soluble and move to a different location. And so if we get these colors that are chroma 2 or less, and not caused by the parent rock, but actually caused by water, then that is unsuitable now. And this is the chart we use for it. Let's see, probably about 15 to 20 years ago, we had something come out called alpha-alpha Diprodil. And I thought that solved all our problem between knowing if something was true soil wetness. We have things that are called lithochromic, meaning the color comes from the rock, or redoxamorphic, meaning the color comes from wetness. And there was a lot of hope that this would, you could come up with an answer in the field quick. It would be correct. Unfortunately, this did not work on most cases. There were some cases it would work, but it's not something that we could use on a regular basis. So my hope was still have to look at the soil and make an evaluation and determination. There is a thing called iris tubes, where these tubes are coated in iron oxides. They're placed in the soil, and if the soil is saturated, then that iron oxide will become depleted, and it will become soluble, and it will move off. And so you will be able to take these tubes out and see where the actual saturation is. This is used mostly out in the eastern part of North Carolina, where they do have true water table issues. Most of the issues we have in the Piedmont Mountains is going to be a Perc water table, not a true water table. But iris tubes are a little bit more indicative than what we've seen in the past. When I started, some of the contractors used a hand level to put in a septic system. And then we would see a tripod with an engineer's level. But here lately, just about everybody has a laser level, and they're self-leveling laser levels at that. So they just, the one on the right is a top con. You put it on top of the tripod, you hit the green button, and it levels on its own. It sends out a beam, and there is a receiver, and the receiver will beep when it hits the beam. The one in the middle is an engineer's level, and you would have to have, for the most part, you'd have to have two people. You'd have to have somebody at the instrument and then somebody with the rod. Where you have now with the laser level, one person can do that. So it's a lot easier with these laser levels and a lot more accurate as well. We have a soil scientist now working on starting to do layouts with drones. You can now fly a drone over a piece of property, and that drone will be able to send a signal to the ground and back up, and it will come up with a contour map. And those contour maps are pretty accurate. And so they're working on being able to do a layout, which is the layout of the septic system, the layout of the nitrification lines, with the drone, rather than having to go out there with the TopCon with the laser level. They'll be able to just one man stand at the site, fly the drone, and come up with a layout. This will be very advantageous for offsites, and we'll talk about offsites in a minute. Systems back then, when I first started, we had basically conventional low pressure pipe and prefabricated permeable block panel system, which most people know as T&J. That was it. There were no other systems. In Guilford, we had to have 36 inches of soil. So we didn't see any low pressure pipes. We saw very few panel blocks. Most everything we saw were conventional. Conventional is rock and pipe. Repair area, well, we were supposed to have repair area, but if you can imagine digging one hole in the middle of a 60-foot triangle, I don't know that we even had enough area for the initial system. We didn't have soil scientists back then. We had Perc hole diggers, PhDs. Our septic systems weren't 3 foot wide, they were 2 foot wide, and they were on 10-foot centers. So there was a lot of things that were different in Guilford because we were under our local rules than what you might see in other counties. Where other counties you would see 3 foot wide ditches on 9-foot centers, Guilford had 2 foot wide on 10-foot centers. So a long-term acceptance rate of 0.3 for a 3-bedroom would be 600 feet, and for a 4-bedroom would be 750 feet. Well, it kind of hit me after a while. I was like, that's not right. It should have been 800 feet for a 4-bedroom. The reason why is because if we went over 750 feet, we had to put a pump on. And so you automatically got a better long-term acceptance rate if you had a 4-bedroom than if you had a 3. Same soil, different long-term acceptance rate. It wasn't done correctly, and I am glad to say that got stopped early on in the late 80s. But why did pumps have such a bad name? Well, they had a bad name because there were a lot of people that would not install the correct pump. They would install these little automatic pumps. And they would cut on and start running about 15 to 20 gallons. And so they were on and off all day long, and they burn out. And so people were having to replace them. So they got a really bad name. Now, with the proper sizing of pumps and the proper installation of pumps last a long time, and they do a really good job with dosing the system. So the bad name they got, hopefully now we're starting to see people come around to accepting that pumps are not as bad as they thought. System types now, we've still got conventional, although I don't see as many. There are still a few. We got shallow place conventional, meaning it doesn't have to have 36 inches of soil. With as shallow as 24 inches of soil, we can place a system at grade. Saprolite, we now use saprolite. Tire chips, we can use tire chips in place of conventional, and there's still areas in the Piedmont or North Carolina that a lot of systems go in using tire chips. We have multi-pipe, we have large diameter pipe, which we see a lot in the mountains, low pressure pipe steel. We have chamber and polystyrene, which we see a lot of chamber and polystyrene. That's probably the largest number of systems we see. And we have one now called low profile chamber. So if we got 20 inches of soil, we could put an at-grade low profile chamber in. Drip technology came about in the 90s here in North Carolina. It came from Israel. They're using drip for irrigation. And so it was brought over here to be used for wastewater. We can also do conventional or low pressure pipe fill, and pre-treatment, reuse, and they continue to come more and more every year. It was funny in that one day on Friday I left and saprolite was unsuitable. It was bad. It wouldn't work. And then come on Monday, and now it was usable. A lot of work went behind this. I say that kind of flippantly, but NC State professors did a number of years research on saprolite to determine that it would move water, it would move wastewater. It was not the cracks and fissures were not conduits that would quickly move wastewater to the groundwater. And we're continuing even now to do more work on saprolite to try to take our rules into a more liberal rule than what we're at now. There was a lot of safety factors put in saprolite when it was first used, and we're trying to remove some of those safety factors because we've used it so long. NC State just this last year did a study on pathogens and saprolite, and it was very positive, but we still got to go a little further. Septic system. Is it too wet? Well, when we want to go and install this septic system, it's got a septic tank, its drain field, and then the soil. Well, just to let you know, the soil is the largest wastewater treatment plant in the world. Just in North Carolina, about 50% of the houses use septic systems. Well, contractor will always want to put a system in, but sometimes it's too wet to put the system in. So all throughout the years, we tried our best to come up with ways to be able to definitively say that the site was too wet. We bought moisture probes, we bought moisture meters, but nothing really worked out. And so it's still us going out there and looking at the soil, looking at the site, and making a field determination at the site whether or not it was too wet. I took the time to ask my father-in-law, who is a farmer. I said, Warren said, how do you know when it's too wet to get in the field? He's been doing this for 60 something years. And he looked at me and he said, well, Scott, he said, go out there and I look at my site, and if it's too wet, I don't plow. If it's dry enough, then I'll plow. And I said, well, Warren, I appreciate your information, but it's something that he's done for so long that really he can look at the surface and see. He told me he would say, look, if there was any cracks, if the surface was dry enough. So he's done it long enough, but we didn't have a precise way for me to know if it was too wet or not. I thought that was kind of funny. Septic tanks have gone in the direction of, when we first started, they were built in place. So you had a lot of block tanks that were built in the hole and are still there. We still see those on a regular basis on these old sites. Then it went into concrete tanks that are usually two pieces. They may be mid-seam or top seam. They're usually two pieces. And now we're seeing a lot of plastic tanks. The one on the right is a plastic tank that is being used in a number of places. And there are some counties in the mountains of North Carolina that haven't seen a concrete tank in 2 years. So plastic tanks have a place, but there is a couple of stipulations that you have to do to put in a plastic tank properly. You can imagine plastic's going to float a little quicker than concrete. Concrete tanks float, but plastic will float even quicker. So you have to over dig your hole, and then you have to place the soil back in with 6-inch lifts and compact it around that plastic tank in order to properly bed that tank so that it doesn't float. We started back when we were doing the cast in place septic tanks. They did a cast in place T. So there's concrete T there. Now what you see is what's on the right, where you have a plastic T with a filter. Every septic tank done in North Carolina comes with a plastic T and a filter. And that's something that's inspected when they go out and look at the final inspection for that septic system. The filter, the idea is it's trying to keep as much solids as possible in the tank, because solids out in the drain field, that's what kills the drain field. So the more we can keep the solids in the tank, the longer our systems will work. Distribution's changed quite a bit also. Used to, we saw D-boxes. They may be used as a drop box, but they're D-boxes or plastic D-boxes or tipping D-boxes. Now we see D-boxes that have speed levelers in it. See that very common. We use multi-dividing D-boxes. We use the flow dividers. We're seeing manatees, which is a pressure manifold built out of T's, plumbing T's, or we see pressure manifolds. So we see a lot of of pressure manifolds and manatees on sites that are pumped. We see a lot of D boxes with speed levelers on sites that are not. If you're looking for equal distribution, you're more than likely going to have a D box on your septic system. Where I came from, most everything was serial distribution, so we didn't always have a D box. Sometimes they would have a drop box. When I started, there would always be a grade board, and so that grade board was placed. It was a 1x6 board. You see it in the center, placed in the bottom of the ditch, and then your 4-inch corrugated pipe was placed on top of that grade board. So basically, all it was something to show you where the 6 inches was, and then you could start your 4-inch pipe and then cover it back up with more stone. They also would have a backfill barrier on the above the gravel to keep the soil from penetrating into the gravel. Neither of these are required now. Gravel racks were used so they could get away from the grade rod, and that's just something that you see the angle iron, the corrugated pipe is tied to that. Place the gravel on it, cut the strings on top, lift the angle iron out, and the pipe is where it's supposed to be in the ditch. Another thing that was developed, it's not used as much. I think some people still use it, but it's a drain fill constructor, where it's a steel box that they pull through the ditch. It's filled with gravel and has the corrugated pipe already placed in it at the proper depth. The one thing is you have to use 100-foot rolls. You can't use 10-foot sections of corrugated. And it makes a real pretty system, but the lines need to be pretty straight in order to be able to use this. Offsites. Well, I came from the land of offsites. When we first started doing offsites, it was basically where you had one lot in a subdivision that wouldn't pass the soil evaluation. So they would come in and they'd find an area offsite and they'd say, okay, we'll just pump this lot over to that offsite. Well, the developers quickly learned that if I've got a site that has a lot of unsuitable soil and another area that has a big block of usable soil, provisionally suitable soil, I'll put all my septic systems over in the provisionally suitable soil, and I'll build all my houses in the unsuitable soil. And so the one on the right, picture on the right, is a subdivision in Guilford County called Wilson Farms. And when you drive in there, you drive by what looks like 2 horse pastures. It's got white picket fence up. They do a very good job of maintaining it. It looks great. It's actually something nice for the neighborhood. But that's where all their septic systems are for a number of their houses. The entire system, initial and repair, is up in this offsite. Offsite's gone from that to now we're having approval. We have an I&E approval and innovative approval for offsites where they're required to be held to a much higher standard. They're required now to have certified operator. Most of them are required to have engineers involved because logistically, offsites can be nightmares, and we learned that. But with this, we're just trying to get to a better place for offsite systems because they're here. They're not going anywhere. They make the developer a lot of money, and so they're going to be sticking around. Flow has changed quite a bit. Prior to 1980, 5-gallon flush toilets. After that, in the late 90s, we would have the 1.2-gallon flush toilets. And now we're even less than that. We have ultra low flush toilets that are lower than that. Shower heads, it could save up to 2,000 gallons per year and 930 gallons per year for aerated faucets. Most of these come standard with houses now. So our flow is a lot lower. We don't have the number of gallons going out. But what happens with that is we have a lower flow, but we still have the strength. So with that lower flow, we have a much higher strength wastewater. So we don't have to get rid of as much liquid, but that liquid that we get rid of is at a higher strength. So we still have that issue. Here's an example. We have ultra low water consumption urinal. That urinal uses an eighth of a gallon per flush, or low flow faucets that use 0.5 gallons per minute. The picture on the far right is called a waterless urinal. It is you see there's no handle there to flush it because there is no flushing mechanism. There's no water. There's no plumbing at all. The canister in the center is filled with oil. And so when you use the restroom, the urine will sink and the oil rises. The urine will go through the trap and out through the plumbing. That canister does have to be replaced on a regular basis, but it's something that you can reduce the amount of water being used. But once again, when you reduce the water, you increase the strength. So we have to always keep that in mind. House sizes have changed quite a bit over the years. Now we're in the middle of, we got tiny houses and we have huge houses. Most of the time, tiny houses are very low water users. Big houses, we're starting to see a big house that's 4-bedroom might use a lot more water than a regular size house that's 4-bedroom, because they have these shower heads where there are like 6 shower heads in the shower. They have the jacuzzi tubs. They have a lot higher water users. So we're looking at that right now as far as our new rules. Field technology, there is a thing called ground penetrating radar, where these sites that we go out on and we're trying to locate the nitrification field, sometimes they're very, very hard to find. When the soil is really dry, it's difficult to probe them out. Also, if you're trying to deal with a polystyrene system, it's very difficult to know when you've hit that polystyrene. With these ground penetrating radar, they can go over top and usually do a pretty good job of locating the trenches. We're now seeing where contractors are getting rid of the person in the ditch. And so they'll put the receiver for the laser on the boom of the backhoe. So they're able to find out if their trench is level without having that extra person in the ditch. And if you're doing a chamber, you don't need anybody in there to shovel the gravel. So it just saves them that extra person. They're also doing a lot of work with GPS on excavators. So you can actually set the GPS if it's already, the layout's already been done and installed on the GPS, then the contractor can have that on his backhoe and it will automatically know exactly where to dig and how deep to dig. Office technology has changed quite a bit. On the left, you see what looked like an old permit where you got the house, the squiggly lines. Now you're starting to see a lot more computer generated, the aerial photos with location of the borings with GPS, location of ditches with GPS, location of septic lines. So there's a lot higher quality permits being developed now than when I first started. Used to, we kidded around and said our permits looked like a pitchfork. You had one line going to a D box and 3 lines coming out. Pagers. When I first started, we didn't have anything. Then we went to pagers. And I can remember being out in the field one time and getting a call, leaving the field, going to a payphone, finding a quarter, calling in the office, and said, "Hey, Susan, it's Scott." And she said, "Hey, Camille was wanting to know where your wife was registered for wedding gifts at." And so I quickly learned that I would not break off doing what I was doing to answer a page. Then we got cell phones, but I'm sure a lot of y'all remember the bag phones where you carried around. That's the first one we had was a bag phone. Then we got the evolution of the cell phone, where cell phones got to where they're really small, but now they're starting to get bigger. But basically now we're carrying a computer. And so we no longer stop work. We now are working 24 hours a day. And we have a computer at our hand at any point in time. It's amazing what all we can do with our phones now. When I started, we had terminals. We didn't have anything when I first started, but then we got terminals, which was hooked into the main terminal. It wasn't a personal computer, it was just a terminal. And we could kind of talk back and forth to each other, but that was about it. Now we went from desktop to thin monitor desktop to laptop to now it's Surface, Chromes. It's amazing what we're able to do. And eventually we're going to be able to carry these little Chromebooks out into the field, and they will have GPS technology that will be sub-meter accuracy, that you'll be able to do the GPS points, put in your soil evaluation, put in all your notes, every bit of that in the field as quick as possible without carrying the big Trimble unit. There's apps now where when I'm out in the field, I constantly look at the Soil Web app, and it tells me what soil series I'm standing on. There's also a soil map app, and it'll show me the soil map for the area I'm at. That way I know if there's a change in the soil series close by. Something it's not always 100% accurate, but it does give me a good idea. Social media, I'm not a big fan of it. I'll be honest with you. I don't do any Facebook, Twitter, Instagram, all that. I just don't do it. I don't know what's coming up. Recent legislation, we had our Permanent Extension Act that did go out on 2020, but that was tough on us because it said any permit that was issued from the year 2000 to 2020 was now valid, and that was a bad thing for a lot of counties because you had to go back and try to find the permit, and then the permit may have been written by somebody that lost their authorization. So then we had to deal with that. Also now engineers can do design flow for bedrooms. When I started, you couldn't touch a design flow for a residence. You couldn't change it. It was 120 gallons per bedroom. Well, now with legislation, engineers now can take a 360 gallon permit and provide a document, and that permit now will be good for 4 bedrooms. So it's 360 gallons, but it's now a 4-bedroom house. We have engineered option permits and licensed soil scientist permits where now engineers can write permits, or at this time with the COVID, licensed soil scientists can write permits, and they submit that to the county. The county doesn't go out and do any evaluations at all on these. They just take that information, and they are a holding house for the file. There's also one where a licensed soil scientist can do a report and submit the report with all the information needed, and the health department will do the permits. That's called a 114. Another thing that's happened is that contractors now can replace D-boxes without a permit. So without coming to the health department at all, they can do a lot of work to a septic system and replace the D-box. That's not the septic tank. It's not the pressure manifold box. It is just the distribution box. So I've talked to a lot of contractors about this, and I told them that it's up to them, but if I were them, I would still request for the health department to come out and at least make a field note and a document to the file that it was done, and it was done correctly. So what's the next 30 years going to bring us with artificial intelligence? I don't know. Probably kind of scary. I certainly am looking forward to 2020 being over because this has not been a fun year for any of us. Who knows? Maybe that we'll have something that we as environmental health specialists will just drive out into the field, we'll evaluate our own site, and we'll go ahead and install the septic system at the same time. Could be. We'll constantly be looking at resource recovery, where the water that's coming into a house being used by the house hopefully will be some kind of a resource that as it comes out, we'll be able to use it. Right now, there are some places in other states that are watering using irrigation water that comes from sinks. So as you wash your hand in a sink, that goes to a different location and you can irrigate with it. We do have schools in North Carolina that are collecting rainwater, and they use that rainwater for fire suppression, and also for toilet flushing. And so it's out there. And finally, are there any questions? I'll get off and see if there's anything in the chat. All right, I see nothing. So thank y'all so much. I think I did finish close to being on time, and I'll turn it over to Kevin.